Die machining, NX Manufacturing. Die machining. This tutorial steps you through the process of machining a die using three-axis contour surface programming techniques. Workflow consists of three parts: setup, program, output. Setup. The setup defines conditions and parameters that are used commonly throughout the program. The setup tasks for this workflow are: analyze the part, choose the setup, define geometry, create tools, specify common operation parameters. Analyze the part. Determine the overall dimensions of the part is the first of five setup tasks you will perform. Open the part and go to analyze, measure distance and check the width as 130. Apply, and this is first select the object, and then second one, this is 130, so 130 by 130. Okay, then measure the height. Here you select projector distance, select the upper topmost face, select the vector, and then select the uppermost face, a point on the topmost face. Rotate the part to see that, to select the top and bottom face. Now 41.5. Okay, you measure the overall dimension of the part to be machined. So knowing the overall part size will allow you to determine clearance distances and avoidance parameters. Measure the height, measure the length, breadth to avoid. Okay, choose the setup. Choosing the setup is the second task. The setup defines the operation navigator and assembly framework. Choose the setup. Go to File, New, and choose the die mold express and ensure units in millimeters and click OK. This setup created an assembly with the part as a component. This allows the NC data to be stored separately from the geometric data. Created a program named 1234. Created a carrier tool carousel tool chain with 30 packets for holding cutting tools. Created some geometry, although you will have to complete the geometry selection. Created some machining methods: rough, finish, semi-finish. This is the program, and this is a datum, and this is an assembly automatically created. Define geometry. Defining geometry is the third setup task. You will verify and edit the machine coordinate system. Number one, define the clearance plane. Define the clearance plane. Specify the part geometry. Number one, you will edit the machine coordinate system. Number two, you will define the clearance plane. Number three, you will specify part geometry. And number four, specify blank geometry. Verify and edit the MCS. The machine coordinate system defines the coordinate system in which the tool paths are output. In the background of the graphics window, right click and choose Orient View Isometric. Click Geometry View. In the geometry view of the operation navigator, double click MCS mill. The MCS origin is centered on the bottom face of the part. You will move it to the top of the part. Click Specify MCS. Select ZM axis arrowhead. Type 41.1 in the distance box and press the enter key. The MCS moves up the ZM axis 41.4 mm. Click OK. Ensure the orientation. Isometric. Okay. Click MCS mill. Click Specify MCS, JDM arrowhead, and type 41.5. That is the height you have measured. Now the access system mode. Click OK. And the clearance option is an automatic plane with a safe clearance distance of 10 mm is created. And avoidance, let us see in the later part of this discussion. Define the clearance plane. The clearance plane defines a safe clearance distance to protect the part from collisions during non-cutting moves. In the mill oriented dialog box, select a plane from the clearance options list. Click Specify Plane. Select Utter Distance from the type list. Select the top face of the part. Click OK if the interpart copy dialog box displays. Type 10 in the distance box and press the enter key. Click OK. The clearance plane is 10 mm above the top of the part. Click OK in the mill oriented dialog box. This already we have seen in the NX. Define part geometry. These steps define the part geometry inside workpiece. The part geometry will be used when creating operations. In the operation navigator, click plus sign to expand MCS mill. Double click workpiece to edit the group. Click Specify part. Select the part body. Click OK to accept the part geometry dialog box. Expand MCS mill. Double click workplace. Specify part. Select the part. Then OK. Define blank geometry. These steps define the blank geometry stock as a solid block surrounding the part. The blank geometry will be used when creating operations. In the mill geometry dialog box, click Specify Blank. Select bounding block from the type list. This creates a block just large enough to contain the part geometry. Type of 5.0 in the ZM Plus box. This adds this adds a 5 mm stock to the top of the block. Note: an alternative way to add stock is to click and drag the ZM plus arrow. Click OK to accept the blank geometry dialog box. Click OK to accept the mill geometry dialog box. The part and blank geometry are stored inside workpiece and will be used when creating operations. Specify blank. Select bounding block and the JDM plus type 5. Then OK and close the mill geometry dialog box. Create tools. Creating tools is the fourth setup task. You can create tools during the setup or as you create operations. Once created, the tools are saved with a path and are available to be used when needed during program creation. Define a roughing tool. These steps define the end mill you will use in the first operation. Click Create Tool in the toolbar. Click Mill. Select Pocket 01 from the tool list. Type Mill 20R3 in the name box. Click OK. Create Tool. Mill Pocket 01. Type Mill 20R3. Click OK. In the milling tool, 5 parameters. In the milling tool, 5 parameters dialog box, the tool number is set to 1. Type the following value in the lower radius box. The lower radius box, you type the number 3. Type the number 3. Okay. Click the holder tab. Click the holder tab. Expand the library section of the dialog box. Expand the library section of the dialog box. Library section of the dialog box. Retrieve holder from library. So double click milling drilling. And type class to search. OK. Now OK, and here you select HLD0010006 medium compression number 3 and section number 3. OK, press OK. OK in the search area and click OK in the search list and machine tool view. Click the plus signs to expand the groups. The tool has been added to the first packet. You will create the remaining tools as you program the operations. Click OK and see the program tab. See the program order view, sorry, and um, in the C 1 2 3 4 5 you have created the program and port navigator. Okay, click mission tool view to see the program that you have created. This is the program you have created, mill 20R3. Okay, next, specify common operation parameters. Specifying common parameters is the last setup task you will perform. Common parameters are parameters such as spindle speed, feed rate, and depth of cut that are shared among multiple operations. These steps allow the in-process workpiece (IPW) to be passed down from one operation to the next so that each subsequent operation can begin machining based on the IPW of the previous operation. Choose Preferences Manufacturing from the menu bar. Click the Geometry tab. Expand In-Process Workpiece section of the dialog box. Be sure the Enable Level-Based IPW checkbox has been added. Selected. Go to Preferences, Manufacturing and Geometry. Enable Level-Based IPW. OK. Define machining data automatically. These steps allow the system to automatically determine a spindle speed, feed rates, and depth of cut based on part material, and tool diameter. In the Manufacturing Preferences dialog box, click the Operation tab. In the Machining Data section of the dialog box, select the Automatically Set in Operation checkbox. Click OK. This concludes the setup. After a quick review, you will be ready to begin the programming session. Go to Preferences, click Manufacturing, and in the Operations tab, check the Automatically Set in Operation. Ensure that it's checked. Click OK. Thank you. Part 1 completed. Review. Let us review so far what we have learned so far. This setup defines information and parameters that are commonly used throughout the program. This setup consisted of 5 tasks. Number 1, analyzing the part allowed you to determine if the part was a standard or metric and to measure the overall length, width, and height of the part. This allowed you to specify an appropriate tool, clearance distance, and stock dimensions. Number 2, choosing the setup defined several items automatically, including the carrier, cutter packets, and an assembly framework that allows mounting fixtures to be merged in. Number 3, Defining geometry included verifying and editing the machine coordinate systems, defining the clearance plane, specifying part geometry, and specifying blank geometry, defining the geometry inside of groups in the operation navigator allows the geometry to be used by operations throughout the program. Number 4, creating tool allowed you to define cutting tools and assign them to appropriate packets. You can create tools during the setup or as you create operations. Once created, the tools are saved with the part and are available to be used when needed during program creation. Step number 5, specifying common operation parameters allowed you to pass the IPW down from one operation to the next so that each subsequent operation could begin cutting based on the remaining stock of the previous operation. You also specified that the spindle speed, feed rates, and depth of cut be determined automatically by the system based on part material, and tool diameter. Program Programming defines the operations that will machine the part. Number 1, cavity mill. Number 2, wrist mill. Number 3, corner rough. Number 4, face milling area. And number 5, Z level profile. Rough the part. You will create an operation that roughs the part. Create the roughing operation. These steps specify the operation type and the parameters that define essential information for roughing the part. Create, Click Create Operation in the toolbar. Be sure Die Mode Express has been selected from the type list. Be sure Die Mode Express has been selected from the type list. Click Cavity Mill. Cavity milling is a roughing type operation that removes material in levels. Specify the following: program 1234, tool mill 20R3, geometry workpiece, method mill rough. The operation will be placed in the 123 program. It will use the part and blank geometry specified in workpiece and use the mill 20R3 tool you created. The mill rough method allows the operation to leave stock for finishing. Click OK. Create operations, cavity mill, and select the mill 20R3 in the tool, geometry workpiece, and method mill rough. Cavity mill. Workpiece, that is cavity mill. Rough the part, cavity mill. We are finishing the first operation, cavity mill. We are doing okay. Click OK. The mold die express is selected. Part specification and blank already done. Now we have to see click generate. Now we have to generate the program. Click generate, and the program is generated. Click verify at the bottom of the dialog box. In the tool In the toolpath visualization dialog box, select current level from the display list. This will display one cut level at a time. Select the pass at each level checkbox. Passing gives you a better view of the cut pattern at each level. Click play at the bottom of the dialog box. Continue clicking play until each level of the toolpath has been played. Click OK to complete the toolpath visualization. Click toolpath verify. And in the 3D dynamics, check for IPW collisions. IPW collisions. One second. And simulations. Select simulations. Stop. This will simulate the complete step in one, but you have the display option current level. Then you click play. Toolpath simulation. Once it is the toolpath visualization completed, now click OK to finish the visualization. Simulation material removal. Simulate material removal. Simulating material removal allows you to visualize the in-process workpiece and should be done periodically as you develop the program. Verify at the bottom. Click verify at the bottom of the dialog box. Click 2D dynamic tab. 2D dynamic tab. Click play. Verify 2D dynamic. Click play. Now toolpath simulation visualization verified. Click OK. Now plus sign to expand the program overview order view. Click OK. Click program order view and check the program you created, cavity mill. Thank you. Remove excess stock. You will create a rest mill operation to rough cut the excess stock. Retrieve a tool. These steps retrieve a tool from the library. Click create tool in the toolbar. Click retrieve tool from library. In the library class section dialog box, click plus sign to expand milling. Click end mill, non-indexable. Click OK. Type 10 in the diameter box. Click OK. Select UGT 0201087 from the search result dialog box. Click OK to complete the tool retrieval. Click cancel in the create tool dialog box. The tool has been retrieved and placed in the next open packet. Click machine tool view. The tool appears in the second packet. Generic machine unused items carrier the UGT. The packet to UGT 021020201087. Create tool. Retrieve tool from library. Milling. End mill non-indexable. Click diameter 10. Additional search criteria. Search OK. And UGT 0201 check once 087, select 087, then OK. And yeah, the name now you can name UGTV. OK, ML committee missions. OK, mission tool view. OK, OK. Edit the tool. These steps edit the tool material. This allows the system to determine the feeds and speeds, cut depth, and step over based on the chosen material. In the operation navigator, double click UGT 021 087 to edit the tool. Go back, close it, OK. And in the operations toolbar, OK. Uh, Geometric view, workpiece, program order view, machine tool view, and the machine tool will double click UGT01 and material HSS coated is already selected. HSS select TMC 0021 HSM ball mill Tian Co. Click OK. Create the rest mill operation. Create operation in the toolbar. Cavity mill. Specify the following: mill RAF and UGT01. Type rest mill in the name box. Click OK. Create operation. Create operations. Cavity mill. Cavity mill. Mill contour. Cavity mill and geometry workpiece. Tool select UGT01 and method mill rough. Method mill rough. Rest mill in the name box. Here you type rest mill. Rest mill. OK. Use the in process workpiece. In the cavity mill dialog box, these steps allow the operation to recognize and remove the remaining stock from the previous operation. In the cavity mill dialog box, click cutting parameters. Click the containment tab. Select use level based from the in process workpiece list. Click OK to accept the cutting parameters. cavity mill dialog box. Cavity mill dialog box. Click cutting parameters. And in the cutting parameters, uh, click the containment tab. And ensure that in process workpiece list. In process workpiece, use level based. Click OK. Click OK to accept the cutting parameters. In process list, level based. Rest mill, mill rough, parameters, in process level based. It's asking for the minimum material removal. Why it's not taking default? Trim by silicate and give it 5 mm. Okay. Okay. Okay, let us see later. Okay, to accept. Okay. Next, generate the toolpath. Click generate. You have to generate the toolpath. Here it is not a mandatory. You can leave it as it is. And this one, let it be none. Now we have to generate the toolpath. Click OK to complete the operation. Click program order view. Click OK to complete the operation. Click program view, and the second operation is now created rest mill. Clean cut small corners. You will create an operation that roughs out small corners the previous tool could not fit into. These steps retrieve a tool. These steps retrieve a tool from the library with a smaller diameter than the tool used in the previous operation. Create a tool in the toolbar. Click retrieve a tool from library. In the library class section, selection dialog box, click the plus sign to expand milling. Click ball mill non-indexable. Click OK. Type 4 in the diameter box. Click OK. Select UGT 0203 059 from the search results dialog box. Click OK to complete the tool retrieval. Click cancel in the create tool dialog box. Create tool. Retrieve tool from library. Milling and diameter 4, type 4 in the diameter, 4 in the diameter. Okay, and additional search criteria and EGT 0201, and the number here is carbide 059, was ball end 4 mm. Okay, and now in the name click OK. Then OK, click cancel in the create tool box. Click OK to complete the tool retrieval. OK, the cancel in the tool retrieval box. Okay, now next step is these steps edit the tool. These steps edit the tool material. This allows the system to determine the feeds and speeds, curve depth and step over based on the chosen material. Click machine tool view. In the operation navigator, double click UGT 0203 059 to edit the tool. Click material HSS coated and 00 TMCO 0021. This specifies a high-speed machining titanium coated ball mill. Click OK in the search result dialog box. Click OK to complete the tool edit packet. Go to the machine tool view. See the third operation and select the material. Here the material is 21 and this specifies a high speed machining and search result box. OK. Create the corner clean cut operation. The click create operation in the toolbar. Click corner rough. Specify the following. Click OK. EGT00 workpiece mill rough. Corner rough. Now we are going to create the operation corner rough. And ensure that the tool you have created is mill rough. Install OK. And it's a corner rough. OK. And select a reference tool. Typically, large diameter tools are used in initial roughing operations. By referencing a larger tool from a previous operation, the current operation can determine the region of uncut material. The material can then removed by a smaller tool. Select UGT 0201087 from the reference tool list. This is the tool you used for roughing in the previous operation. Reference tool. Reference tool. Select UGT, OK, and reference tool. This is the tool you used in the previous operation. Reference tool UGT 059. OK. And generate the tool path. Click generate. Click OK to complete the operation. The program order view. Click program order view. Corner of is now complete. Generate. Do you want to stop the process? The reference tool is smaller than the cutting tool. This and will be ignored. No. You take that reference tool is stop. Let us see. Reference tool is 051. Reference tool is what we have selected, right? Reference tool is what the previous 087. We have to select the previous tool, then generate reference. Now corner rough has been created. Finish flat areas. You will create an operation that finishes the floor and other selected faces. Corner rough. Program corner rough is created now. Finish flat areas. Define a finishing tool. These steps define the flat bottom and mill you will use to finish the faces. Click create tool in the toolbar. Click mill. Pocket 04. Select the pocket 04 from the tool list. Pocket 04 from the tool list. Type mill 15R0 in the name box. Click OK. Create tool. create tool. Now the tool create tool, click mill is there, select pocket 04, mill, select pocket 04, pocket 04, then click OK. Type mill 15R0, mill 15R0, mill 15R0, mill 15R0. Click OK. Now in the milling tool 5 parameters dialog box, type 15 in the diameter box. Click the holder tab. Expand the library section in the dialog box. Retrieve tool holder from the library. Retrieve holder, click OK. And material, retrieve whole tool, OK. And milling drilling, select milling drilling, OK. Tool retrieval, okay. Double click, okay. Holder section, tool, okay. The tool, tool program database. Type 15 in the diameter box. Type 15 in the diameter box. 15 in the diameter box. Okay, now it will work. Okay, and then click holder tab, click holder tab, and here, and retrieve holder from the library. You have to retrieve the holder from library. Select milling drilling, and class to search, click OK in the library selection, and in the library selections, go to HAD006 medium compression matching list. Click OK to search it. Click complete. Click complete. OK. Now create operation in the toolbar. Click face milling area. Specify the following. Click OK. Mill finish work ML 15R0. Create operation. Create operation. Sea level contour milling. Now we have to select face milling area. Face milling area. Face milling area. Okay, now see that 59 mill or 15, mill or 15, 0 is selected, and then type the following, mill finish. Now it is mill finish and face milling. Okay. Specify cut areas. These steps specify the faces to finish. Click specify cut area. Select the three faces indicated below. Click OK. Specify cut area. Select this face, second face, and third face. Click OK. Now generate the toolpath. Now the zigzag pattern does a good job of unidirectional cutting, either climb or conventional, but it generates many engages and retracts. Generates many engages and retracts. Generates many engages and retracts. generates many engages. Okay, done. Next, change the cut pattern. Follow periphery will do a better job of keeping the tool continually engaged in the material. You will also specify a cleanup pass for islands and specify wall stock to the walls can be finished in the next operation. Select follow periphery from the cut pattern list. The cutting parameters, click the strategy tab, select inward from the pattern direction list. Expand the walls section of the dialog box. Select island cleanup. Click OK. Follow periphery from the pattern list. Click cutting parameters. Click cutting parameters. Follow strategy tab or finish extend to point outline. Allow undercutting. No. Cutting parameters strategy, click strategy tab is already clicked. Okay, and the strategic tab pattern directions, inward pattern directions, conventional cut, specific, wall cleanup. Okay, and finish plus out finish, extend, allow cutting. Okay, allow undercutting. No, inward, select inward from the pattern direction list. Cut pattern, follow periphery, cut pattern. This and all, it is advanced now. Okay, expand the walls section of the dialog box. Expand the walls section of the dialog box, and that wall section of the dialog box, island cleanup at the end. No, what is this? Cleanup. Click OK. Zigzag. Okay, now what happens? You must specify walls to define, specify walls. You must specify walls to define wall stock in the operation. Specify wall geometry. Click pre-select. Expand the list section of the dialog box. Select one from the set list. The faces adjacent to the cut areas have been selected. Click OK. Specify wall geometry. Expand the list. There is nothing like that. Select pre-select and one from that. Click OK. Specify wall stock. Leaving behind some wall stock prevents the tool from finishing the wall and the floor at the same time, eliminating tool chatter. Click cutting parameters. Click stock tab. Type 1 in the wall stock box. Click OK to accept the cutting parameters dialog box. Cutting parameters. Okay, cutting parameters. Click stock tab or stock tab. Okay, and in the wall stock, type 1 in the wall stock. Type 1 in the wall stock. Type 1 in the wall stock and click OK to accept the cutting parameters. Click OK to accept the cutting parameters. Specify a helical engage. A helical engage is best suited to an operation like this one that has very small stepovers and uses high speed machining data. Click non-cutting moves in the closed area section of the dialog box. Select helical from the engage type list. Okay, non-cutting faces, non-cutting moves. Select, click non-cutting moves in the closed area section. In the closed area section, okay, and section, select the engage type. Engage type is helical, and click OK. Generate the tool path. Click generate. Click OK to complete the operation. Click generate. Click OK to complete the operation. Finish the remainder of the part. You will create an operation that removes the wall stock specified in the previous operation. Define a finishing tool. These steps define a ball end mill with a radius slightly smaller than the smaller inner radii on the part. Click Create Tool in the toolbar. Click Ball Mill. Select packet 05 from the tool list. Click OK. Type the following values in the ball diameter and length dialog box. Okay. Create tool. Ball mill. Select packet 5. Select packet 5. Click OK. And ball diameter 1.75, 57. Ball diameter 1.75, 1.75, and the length 57, length 57, length 57, length 57. Okay, length 57. Okay. Click type, click OK. Click OK. Type the following values in the ball diameter length. Okay, click hold a tab. Click hold a tab. Retrieve folder from the library. Milling drilling. Go to milling drilling and type milling milling link from the class to sources. Click OK to library class selection. OK to class library selection. And from this HCD 006 medium compression and OK search list OK to complete. Okay, create the final finishing operation. Create operation in the toolbar. Create operation in the toolbar. Z level profile. Specify the following. Okay, create operation and this time Z level profile. Z level profile. Z level profile is in contour. Z level profile. Z level profile. Check that mill finish workpiece ball mill workpiece mill finish. Click OK. Next, select faces. These steps specify the faces to finish. In the background of the graphics window, right click and choose orient view top. Graphics window, right click, orient to top. Click the specific cut area in the background of the graphics window, okay, click and drag diagonally to form a rectangle that encloses everything except the other edges. That encloses everything except the other edges. Only the faces that are entirely within the rectangle should be selected. Entirely within the rectangle should be selected. Specify cut area. Deselect faces. These steps remove the two faces that should not be finished. Hold down the shift key and select the two top faces. This deselects the two faces that were finished in the previous operation. The number of items in the list should read 188. Click OK. Be sure constant has been selected from the common depth per cut list. Type point 2 in the maximum distance box to specify the depth per cut. Okay. Okay, hold the shift key. Oh, sorry. Specify the cut area. Hold the shift key. Deselect. Okay, and custom data. Ignore loops. Be sure constant has been constant. Ignore loops. Nothing is there. Type point 2. Enter in the maximum distance box to specify the depth of cut. What is maximum distance tab? I don't know. Okay, next one is in the background of the generate toolpath. In the background of the graphics window, right click and choose orient view isometric generate. Isometric and generate. And generate. Ramp on part. These steps change the method by which the cutter moves from one level to the next and will do a better job of keeping the tool continually engaged in the material. Z level profile path dialog box, click cutting parameters and select ramp and part from the level to level list. Level to level list, ramp and part, cutting parameters and ramp select go to connections level to level and in the level to level ramp on part and select cut between levels. Select use depth of cut from the step over list. Use depth of cut in the okay. Use depth of cut from the step over list. Click OK. Click OK. Cutting button is OK. Click generate. This is specific cut area. Okay. Click to generate. Control the engage and retract points. You can improve the tool path efficiency further by minimizing the engage and retract distance. Click non-cutting moves. Click transfer rabbit tab in the between regions section of the dialog box. Select previous plane. from the transfer type list. In the within region section, select previous plane from the transfer type list. Click OK. Non-cutting moves, and retract, non-cutting moves, transfer and rabbit, tab. In the between sections of the dialog box, select previous plane. Select previous plane. Within region section, transfer type, previous plane, transfer type, previous plane, transfer it. Click OK. Generate the toolpath. Click OK. Generate a toolpath. Click OK. Simulate material removal. These steps simulate material removal for the entire program. Right click 1 to 3 and choose toolpath. Verify. Click 2D dynamic tab. Click play. Click OK to complete the simulation. This concludes the programming session. After a quick review, you will be ready to create the output. Review. Programming defines the sequence of operations that machine the part. Number 1, creating the program defined the sequence of operations that cut the part. Number 2, generating toolpath allowed you to see the toolpath and tool movement for each operation. Number 3, simulating material removal allowed you to visualize the in-process workpiece. Allowed you to go to program tab, program view, program order view, and right click it, and if you click simulate, generate, simulate workpiece toolpath, simulate, we'll see the entire tool movements. Okay, close, save. Now output. This tutorial covers the basic steps required to post-process and output shop documentation as part of the overall machining workflow. For details on how to create, install and download post-processors and customize shop documentation output, see the output tutorial. Post-processing converts the generic internal toolpath data into a format compatible with a specific machine tool controller combination. To post-process, you need a toolpath and a post-processor. To click post-process, operations must contain generated toolpaths. Each operation should display a repost or a complete status symbol. Click program order view. Every operation in the program displays the post status. Post-process. These steps would post-process the program. In the operation navigator, click 1 to 3. Click post-process in the toolbar. Choose Tools, Operation Navigator, output NX Post-process in the menu bar. Program Operations Navigator. Operations Navigator. So, order view, Programs Navigator. Right click. Okay. Click operation in the operation. Okay. Click 1 to 3. Okay. Click post-process in the toolbar. Click and post-process in the toolbar. Post-process the toolbar. In the toolbar, choose Tools and NX CAD OK Post Processor. The generic post processors provided by the system are displayed in the post processor list box. In the post process dialog box, select Mill 3 Axis Turbo from the post processor list. Mill 3 Axis Turbo from the OK. Click browse for an output file and specify a directory you can write to. Browse for an output file, specify a directory, you can write to. Specify a directory, um, G colon 3D manufacturing. OK. Create a for PP. Then OK. Then OK. Okay, browse for an output file. Here is okay. Okay. And click OK. The toolpaths are browsed, processed, and listed in the information window. Click close in the windows. Click close. Okay. Then shop documentation. Shop documentation output is based on an object selected in the operation navigator. If the selected object is a group, then all objects inside the group are processed. If the selected object is an operation, then only the operation is processed. Output is generated in text or HTML format depending on the selected template. Siemens die machining program sheet, part name, okay, cavity mill, operation name. The shop documentation function provides HTML templates that are customizable using Excel. Text templates are also provided but require editing in TCL. For information on how to customize HTML templates, see output tutorial. In the operation navigator, click program, shop documentation. In the operation navigator, click program, shop documentation, click shop documentation. In the toolbar, choose information shop documentation. The contents of the report format list will vary depending on how your templates have been customized. Click OK in the browse for an output file, and click OK in the browse for an output file. OK in the OK. Okay, HTML Excel. Okay. For HTML outputs, you may need to click yes in the MS Excel dialog box to display the graphic images. Click close in the information dialog box. The operations tab contains a column of the operations tab contains this is what has been generated. Siemens program sheet, part name, material, machine, and the program sheet. Okay. Click choose file, close all parts in the menu bar. Click no close. File, close all parts in the menu bar. In the menu bar, click, click. Okay. They are asking me close shop. Okay. This one you close it, and then go to file, close all parts, and then click no close. What is no close? I don't know. Click no close. Okay. Hmm. A review. Creating output is the last part of the workflow. It allows you to post process and to create shop documentation. Number one, post processing converts the generic internal toolpath data into a format compatible with a specific machine tool or controller combination. To post process, you need a toolpath and a post processor. Each operation should display a repost or a complete status symbol. Shop documentation output is based on an object selected in any view of the operation navigator. If the selected object is a group, then all objects inside the group are processed. If the selected object is an operation, then only the operation is post processed. Output is generated in text or HTML format depending on the selected template. This concludes the tutorial. To begin another tutorial, click Internet Explorer tab located along the edge of the graphics window. Point to an image on the home page to display a description of the workflow tutorial. Click the image for the tutorial you wish to walk through. Thank you.